Hello and welcome today to our webinar. My name is Gabe Prado with Cognite. I'll be moderating the conversation today. I'm really excited to introduce our topic just around how generative AI is improving Aker BP's data management practices. So it should be some really excellent content today and discussion. I'd like to quickly just introduce our panelists today. We have Oystein Asboy, the Digital Platform Manager for Aker BP, and Reza Rosley, data scientist with our global delivery department here at Cognite. So thank you both for joining. We're really excited to have you.
Thanks.
Yeah, and now before we get into content, I'm just going to go through a few pieces of housekeeping. We've got about an hour allocated for this content today. We'll spend about 45 minutes on discussion and then leave some time for Q&A at the end. So we're kind of going to be using a little bit of a fireside chat style here. So a little bit more conversational, a little bit less formal. We'd love to hear questions from you. So if you have a question about anything that's being discussed, please submit it in the question box, which you can find in the Zoom panel. And then lastly, we are recording this webinar. So if you want to revisit any topic or if you want to share, we'll make sure that this video is distributable after the fact, and then it'll also be on cognite.com. So thanks again for everyone who's joining today. Really excited about the content, and we'll go ahead and kick things off. Now, kind of starting with a little bit of conversation and setting the stage here. What I find really interesting about industrial digitalization is, we've been at this for a long time, and everyone's still trying to use data better. But the fact is, using data for daily decision making still requires a lot of effort and is still pretty hard. So I'd like to kind of pose this question to both of you. What are some of the challenges here, and what are you seeing and what are you experiencing kind of day in and day out?
We have a long history of operating our offshore assets. So the oldest one is built in the 80s. So time is not doing us any favors here. So due to the history, the data is also distributed over that amount of time. So we have data in different formats and data in different levels and of different age. So it makes it hard to go back and do everything from scratch in a newer format or according to today's specifications of an asset.
Yeah, just to build on that, Oystein, from what I know about Aker BP, there's been a lot of mergers and acquisitions. So you inherit assets, not just legacy assets, but from other companies. We have different standards, and there's a lot of work, right, to kind of put it into a unified standard across all your assets.
Yeah, definitely. So even if it's two new assets built by two different companies, it will still not necessarily be the same, right?
Yeah.
Yeah, I think what's interesting is that the sheer amount and different types of data as well, right? Because you're not just dealing with time series, you're dealing with documents, you're dealing with a lot of unstructured data as well. Could you maybe spend a little bit of time explaining that?
Yeah, the easy way is to just store stuff in a document or as an image or something that is not that easily compromised or which holds its history over time. And also due to the history of the oil and gas business, a lot of things are built up by the process of handling information from one party to the other. And unfortunately enough, in a lot of cases, it's done by documents.
Yeah. So a lot of times is data is handed over through documents from interface to interface. And I guess to move on to this slide, well, what remains to be true is that data remains kind of hard to trust, right? From what we've seen, when we look at the different data sources in Aker BP, some of the data is sparse, right? And it's outdated, it's incomplete. And what's interesting is sometimes representation of a given, for example, equipment, they can contradict each other. So if you, from the perspective of SAP, or if you can look at it from the perspective of a 3D model, or you can look at it from the perspective of the engineering data, right? Then we see sometimes that these sources of information represent the same things, but they have a tendency to be kind of conflicting or contradictory.
Yeah,
Yeah, definitely that is a problem. Yeah.
What kind of jumps out here is, right, just due to the sheer volume of this, this is a really hard problem for humans to solve manually. I think you can do it in small bits and chunks, but again, it doesn't solve the broader problem of maintaining this data over time and making sure that that data store is always up to date. So I think it's a really hard problem to solve manually. And when we're doing some of the prep, Oystein, I think you had a really good example here of just kind of the sheer scale of this problem.
Yeah, so what you see now is one place where we hold a lot of information. So we have a tag master which holds the asset information. Not all of the information is supposed to be there, but a lot of information could be there, and some information is there, but it's like half of the fields are empty. And then some of the information might be structured in a different database, which is built on a more modern solution where we actually have the information which is needed in a structured format, but not for the old assets, right? So how can we pick up the pace for those old installations and assets to get up to the speed of the new ones, which actually have the data in a structured format where we can show it to the users without the users need to scroll through a document of 100 pages to find that exact specification they're looking for.
Yeah. So just to add on this, what you're seeing here is like there's a lot of empty fields, and a lot of this data is not that it doesn't exist; it exists in documents, right? So it just hasn't been kind of what we say liberated and put into a proper database format, and that's a lot of kind of information that's lost that could be used for different things, solutions, applications, and yeah, we'll get more into that down the presentation.
Yeah, but it's an interesting point, right? Because doing this with current methods requires a ton of manual work to populate all that, make sure it's able to be trustworthy, and we just don't always have that time.
No.
So I think this is what brings us to the topic today, right? You all set up the problem really well, but generative AI is an intriguing solution to some of these really manual challenges. And I'd love to get into some of the use cases and opportunity that Aker BP sees is using this new technology to kind of address some of these really challenging problems with data. And I'd also love to kind of unpack, where's Aker BP on the journey right now? So Oystein, probably a question for you, but what are your thoughts here?
Yeah, so we have been going around a bit in the company, asking people if you had the ability to do the information gathering or qualification of the data in scale, how would you do it? And how does your process look like today? What is the issue today? And we have identified some of the areas where a tool like this can be used, and we are also going to test it. So we have been looking into brownfield modifications where we set out a big package of information to a vendor which is going to do a modification on one of the existing assets. We have looked into supply chain, how we handle information in that domain, and also how we present information from a life cycle information point of view. How are we able to give the users insight into that vast amount of hidden information that lies in a document or in a lot of documents? Yeah.
And what is some of the impact, right, for solving these use cases, right? There's always business impact here. Well, can you share a little bit more around like why solving these use cases is valuable?
Yeah, so in a lot of these, when we move information, there's often a lot of manual processes. So to be able to help that manual process to give at least us a really good starting point when you receive, let's say, thousands of documents, where today in some processes people sit down and just punch this information manually or look through the documents manually to find the information they need and punch it into whatever system is going to be needed to do an analysis or modification or whatever. so we can give them the opportunity to get at least a really good starting point with giving a structured start to this process with a lot of information up front.
And I can imagine that when this data is available, right, it makes it easier to deploy dashboards and deploy analytics and give people more line of sight into the operations that they're trying to run, right? So I think this is a really foundational piece. You get that data piece right, and it can unlock a lot of different value and new insights that you probably haven't thought about before.
Yeah, so this is just the start of that process that we are going to look for this opportunities to use this functionality, and happy to have Cognite to build the functionality into the tool so that we can utilize it where we actually need it.
Yeah, absolutely. And I think this is where Cognite and Aker BP intersect, because I know our visions are aligned, right? We also at Cognite want to make sure that data is extremely available, trustworthy, because at the end of the day, we're trying to solve an adoption problem, right? When data becomes easy to access and you can trust it, multiple different stakeholders across the data value chain then have access to do their jobs better and with less manual effort. Right. So all the way from the data engineering side, where you can use generative AI and some of the data ops capabilities to make data easier to integrate and then contextualize, which is a really big challenge today. We also see opportunity here around better data modeling, which I think we'll showcase in some of the demos here today as well. And that affects a different set of stakeholders. And then at the end of the day, there's also generative AI features that can be used at the end user level in the business environment, such as SMEs just needing better access to their data to be able to query it more easily, be able to quickly create different analyses and different chartings. So this is some of the vision that Cognite is also trying to take to market. We've already built generative AI into a lot of the different data value chain. And I think by us doing this and partnering with the domain expert on your side, right, we're able to really see where this can have value. You had a really good example in our prep, Oystein, around just some of the challenges that are being solved by Cognite just from a sheer volume perspective. Do you mind sharing a little bit about that?
Yeah, so if you look at it on a SME point of view, we have a lot of users which are responsible for a part of the process or a certain piece of the large puzzle of the business that we're running. So it's really hard to get that overall alignment of data, right? So when we contextualize in the more modern tools like a cloud environment or a data platform where we're going to do analytics on a larger scale of data, where we're going to compare stuff and figure out clever things, it's really hard to get one part of the data that comes from one part of the company to match up with the others. So that's really hard, and to give the users the insights into that analytics fast and easy is really important for them to be able to go back or to adhere to the same ways of modeling and organizing their data. So that's a really good benefit we see from this, that we are able to give them insights or give them the ability to do fast analytics on a large amount of data, which can be really hard to organize if you have to do it manually.
Yeah, for sure. So I think this brings us to some specifics, right? Yeah, we're working closely with y'all, right, on certain elements of generative AI, specifically around the data management problem. So on that previous slide, those two top buckets. Let's spend a little bit of time talking about these features that Reds, I don't know if you wanted to kind of start here with some of what's really exciting and really engaging.
Yeah, so just to talk about something tangible that we're developing internally within Cognite is this tool, what we call right now is a document parser. So generally what it is putting unstructured data to structured data. So unstructured data from like documents, files to what we put into our graph database, which is called the data models. As you can see on the left, it's just a document, and then we make some structured digital representation of it on the right. And you can use this transform structured data to do all the other cool stuff, like queries and connect to applications and build solutions on top. So that is the kind of a component that we are kind of focusing on in Cognite right now.
Yeah.
Just to give a high level overview, this is our what some people will be familiar with as the Cognite roadmap. And where does this kind of new AI capability fall under? It's part of our data onboarding kind of program. Specifically, we're looking at ways generative AI can be used for data onboarding. And then we've highlighted through like discussions with Aker BP and other companies that this document data extraction tool using Gen AI is one thing that can really drive business value. Of course, CDF is a kind of a stack of tech of tools and capabilities. You can see blurred out there is industrial digital twin and then industrial solution applications. And we are also focusing on other kind of AI aspects from onboarding to user consumption. So that is a higher level roadmap. Next slide. So what are we trying to solve? Well, with the solution, one of the biggest things, of course, is time savings. As we've iterated, a lot of man hours is used on extracting these information, punching in information to databases from documents, and yeah, reducing also errors. So over time, if you're dependent on human having to do these repetitive steps, there's high likelihood that there'll be some errors in the kind of inputting of data. So this helps reduce that. Also, the consequences that we're ensuring like a solid data foundation. So kind of solving this sparse underlying data issue. So if a database that is dependent on these set of documents is quite empty because the task hasn't been completed of like manually kind of punching in the data into the database, then yeah, you don't really have a solid data foundation to build anything on top of. And yeah, it's putting this documents into kind of our graph database data model. So we're populating instances of a data model. Next slide. So yeah, this is just to kind of drill that down, right? At the bottom, what you see here is kind of how our data models work. From the source system, we do a source data model representation. So source system like structured databases, and we kind of transform it to our source data models. And then we have domain data models in between. It could be anything. Aker BP has a domain data model. One example is Shifos. One example is ISO 14224, and so many other ISO examples, and more coming up. And then you can connect these domain data models to solution data models, which could be an application or a specific solution that you build upon. So this is a kind of a really cool architecture where you have like in between domain data models and the applications built on top. And a lot of our Cognite applications are built this way. But then kind of the interesting thing is that what's not included in this flow are the document repository systems, the files and stuff. So this data does not make its way into a source data model as of now. So the only way it can make into your applications or solutions or use cases is if someone manually punches it. And then many cases, this would be done many number of times. So you could perhaps end up with many different versions of what you could say is the truth. And yeah, it's quite a mess. And we're trying to use this document parser tool to mitigate it. So how does that work? One more slide, Gabe. In this context, I would say, is that we would go from the document repository systems and we would use this tool to kind of make a digital representation in some form. So in the source data model, so that, yeah, you would have hopefully one version of a value of a representation of a pump and its attributes. And then this kind of source of truth can kind of propagate through the system. And we're all referring from one single source of truth. ideally, and not representations of people's inputs. So that's the idea. Next slide, Gabe. Yes.
Actually, yeah, hand this over to you real quick. But I'm excited about a demo.
Yeah. I was told to do a live demo, so I will. And it's a bit risky, but we'll go through this. So this is what we have right now. What you see here is Cognite Diffusion, which is our user interface built directly on top of CDF. And this is for Aker BP's kind of sandbox playground. We're looking specifically, we have different resource types, but we're looking at the documents in the project, this Aker BP sandbox. Right now, you can see there are 18 files. There are pump data sheets from a source called D2. And then if you look into them, they're all kind of slightly different, but they're data sheets on pumps. I think mostly all sorts of pumps, not just centrifugal pumps, but these are the kind of documents that we are kind of looking at. And as you can see here, there's a lot of information, and a lot of this information, I don't have it shown here, but it's not in a structured database. So these things that you see, a lot of this resides only within the document, and it's not in any other source system. So if a user needs to find like what is a liquid this kind of pump is servicing, you'd have to really just only find it here, and all these kind of details. And I guess from the shoes of an engineer, these things would be very useful for calculations and knowing like what is the operating range of a pump, what is the fluid, what's the specific gravity that this fluid is, you know, so that you can do other calculations down the line. So basically, we have a bunch of documents that look very similar to this, but slightly different. And we're not this tool does not kind of cater to a specific kind of document, but it can be run on different kinds. Even if the layout of the document is slightly different, then it's okay too, because it's all handled by GPT. So what we do, we have our document of interest. We go to our data models, and we kind of create on the left side here kind of a graph database representation of what we believe it should be. So I kind of inferred this graph representation here, that pump should have tag, service, manufacturer, model, serial number, and it also has these sub schemas. So it will have a general schema with number of stages, motors, performance here with all these properties. And kind of the simplicity about this is just what I'm inputting is just on the left. And that's basically all that you see. I'm just typing out the schema, what is a property and what is a data type. And that's it. I'm not saying find this property in this area of the document. That's all handled by GPT. So I'm not going to run the tool right now, just to save a bit of time. But what we're doing right now is basically saying to the LLM, find these properties within these group of documents. And then it executes, and then it returns kind of these instances. Here, let me reload one sec. Yeah. So it returns instances from the documents, and every row represents one document. So you can see it's extracted the tag number for this document, the service for this document, manufacturer, model, serial number. And probably just to kind of drill down in detail, we can see here, let me search for this document specifically. And we can see, yeah, these are the properties you see just now: jet, water pump, manufacturer, Sundyne, model. And yeah, it's able to extract almost an identical representation. So if the data from the document is not like ideal, there's not much that the LLM can do, but at least it's giving you pretty accurate, I would say, copies. So like even this is all capitalized for service, and we can see it's all capitalized here. So, and yeah, it's also populated the other sub kind of sub views number of motor stages, number of motors, number of stages, motor provided, and also the operating conditions here. So maybe we should drill into this. But what we're seeing is that it's returning it in the correct type. It's returning as a number, as a float, not just a string. And this is very important to kind of do proper queries, right? So you can ask things like, give me all the pumps within capacity of like 10 to 100 meters cubed per hour. So, and it will return you these kind of the results using a GraphQL. As you can see here, these are all the representations. Even if understood, what is the unit of measure? So one of the fields I wrote is like, what is the capacity rated, and also what is the capacity rated unit of measure? And it does the same for differential pressure and what is its respective unit of measure. And yeah, and there are some empty instances, and in most cases, the information is actually empty. So that's quite reassuring that it's not necessarily, it's not hallucinating. We're giving it the document, so it's looking from the context of the document, and it's kind of returning the truth. If it doesn't exist, then it won't return you the information for most instances. So we're really, I won't say completely mitigating hallucination, but really, really reducing the likelihood of hallucination by providing it the context of the document, right? Yeah, and this kind of orchestration of 18 pumps is only possible by the foundation of CDF. So I was able to query, like I was able to ask for all these documents from this data source of this type. So this is the knowledge graph that we are kind of leveraging on, the CDF knowledge graph, to enable this tool to do this task. And then this information is repopulated back to a graph database. So this is kind of giving substance to the claim of knowledge graphs in LLM and how they complement each other, right? So the only way we're able to do these orchestrations at scale is because of the current CDF knowledge graph. And I would go into some really cool details here, but I do believe there's some limited time. But I guess you have an idea. Gabe and Oystein, can you let me know if I'm missing anything that I should be demoing?
No, we
Maybe.
saw in an earlier demo that if there were no specifications for a liquid in one of these example, it would not say an empty field. It could actually say NA. This is not something I would have in this document. So that feeds up under the hallucination part of it. If it's empty, the value is not there. And if it's a specification which is missing, it could say NA. So this is not a specification which is covered by this specification.
Yes. Yeah, if it says NA, then it'll return NA as well. So yeah.
And then you showed something earlier around this. We discussed this earlier with regards to the input values you give, what you ask for. You ask for liquid now, but it doesn't necessarily say liquid in the document, right? It could say use a different word for it.
Yes, so it understands some semantics, and if like for example, if if liquid is not enough for as information to provide, you can add more descriptions. So we've kind of embedded this feature into kind of our tool, where, for example, efficiency at rated flow, it could return a decimal, but then I pass this context, this description here, and it's not just a representation. This information is actually passed to the large language model, and then it will take that into account, right? So we use these descriptions to kind of better prompt the language model to give a better result. So we're using some prompt engineering kind of tools. All right.
No, I think this is a great example. Yeah.
Sorry.
Yeah, no, I think it's a great example, Redza. Again, it's always cool to see generative AI not in slide form and actually in a demo. So that's excellent. Yeah, anything else that you wanted to cover here before we go back to the conversation?
No, I think it gives everyone a taste of what we've been doing, what we're kind of working on and focusing on, and what we're still developing and maturing. So
yeah,
back to you, I guess.
Absolutely. And I can imagine, right? This clearly speaks to trust, right? We wouldn't want to fill our data stores with a bunch of hallucinations, right? I can see that being extremely risky in an operational environment. So the fact that we're using something that's very explainable, that knowledge graph, which is very, very explainable, to create outputs that we can trust is really, really important.
Yeah, and you also need to be able to adapt it, right? So in one context, you could use this information, but in another context, you would only like to show it as additional information, like for the more operational side of our business out in the sea, you would like to probably tell people that this is information that is taken from document using AI. And it's additional information to the trusted information from a source, for instance, so that you can easily define between the two.
Exactly. Yeah. So just to kind of add a little bit more here. So what we're doing, what I showed was the unstructured to structured, and we make a digital representation, and then in between these processes, we will have data quality checks, and we're working on kind of data quality features that will kind of give more trust to the data, or like highlight to the user, okay, this is probably a bad kind of detection. Check this out. And there are many things that we're kind of looking at right now to kind of mitigate those. And then once we have the structured data, trusted data, we can do transformations to different data models. So this pump can go to a pump Shifos data model and transform to populate that kind of ontology. And you can, yeah, next slide. And also we can populate other ontologies as well here. Aker BP has its own data model. And like I said, these other data models, ISO 1424 and Shifos and so on and so forth. So this is kind of the idea of how this would work. And you can query data in a way that you're more familiar with. So if you understand data through the lens of Aker BP, perhaps you can do queries there. And then, but if you're kind of more into maintenance, then you can do it from a maintenance data model view. So it's, we're trying to kind of develop some ecosystem here.
Yeah, and we'll get into some of this as well, but right, what are some of the time savings with using this approach? I know it's still a little early, but like what are you seeing so far? Like where's the time savings?
So if I can use that example and give you some numbers, it took around like probably 45 seconds per document to do the extraction on that data model. I don't know, it's hard to say. We didn't do a stopwatch test, so like actually seeing how long it takes for a person to do that task themselves. So we know that other companies have done that, so they have data on how long it takes to do such a task. But I don't know, I would say probably 4 minutes, 5 minutes probably to do that document, not taking into account a bit of breaks here and there. So on average 5 minutes. And if someone has the attention span to do it consecutively, that's another thing to take into account. Yeah. But yeah, so 5 times faster perhaps. Sure,
plus at higher quality, right? Assuming that we can trust the outputs, right? Because human gets tired, right? You start to potentially have quality issues and such, right? So programmatically, this is a really interesting solution.
Exactly. And if there are errors, GPT would likely do more systematic errors. So there would be like a systematic kind of trend of issues, which is easier to correct than a random human. Maybe at the beginning, yeah, he or she was more attentive, but then later in the end, yeah, he or she like the attention drifts. So you never know where the error could pop up. So
yeah, absolutely. Well, I think this is a nice bridge here, right? Because, you know, we solved some very specific, or we're solving some very specific challenges with this technology today. You know, kind of passing this back to you, Oystein, what does this mean, right? If you're able to solve this, can you share a little bit more about what this means for your team, for Aker BP?
Yeah, so we touched upon it earlier as well. So we are able to make more data available for everyone in a faster and easier way. So you don't have to look for a document and that specific correct document, or so that is something that we're looking into. We have found some specific processes where we do manual data loading, where this tool can be used, where we today get documents or have documents where we load the data manually into our system. And also together with Aker Solutions, we are looking at this handover process or modification process where we are modifying something old, which is handed over with a lot of documents. Can we ease that process for both of us to get that information handed over automatically or in addition to the document, so you have a better starting point when you start the analytics on what you're going to do.
Yeah.
And
sounds,
there are
yeah.
probably yet more to come, right? So it's just the start of the ability of tools like this.
Yeah, no, absolutely. I think this comes down to, you know, this has been a journey, and I'm sure there have been plenty of lessons learned. Could y'all maybe share a little bit? Maybe we'll start with you, Oystein, again. Just what are some of the lessons learned so far in this process?
Well, it's I thought we were done with the manual loading of data, but it's not that easy, right? So that is a learning that we still have ways to go with the process of how we are working, and maybe we can take some leaps. We're using this technology. Also, it's a great tool for the history that we have with older information and older systems. And then we have learned things around how our data is stored and handled in Aker BP as well. So if you're missing data in a system, there might be a reason for it as well. So that's another learning we have had. Yeah.
Yeah, for sure. What have you seen so far, Redza?
Yeah, what seems is like the industrial data space is not as mature as maybe one would think it would be. So once you really like drill into things, there's still very much outdated processes. So there's a lot of opportunity in that sense, right? For reducing operational inefficiencies and really like optimizing processes. So it's kind of exciting in that sense to see that there's so many challenges and so many things to work on. So yeah.
Yeah, for sure, for sure. Well, I've been seeing some questions kind of come in through, so we'll get to Q&A here in a second, but just wanted to wrap up the content here a little bit. And I think what really jumps out here is that, you know, to really become next level in digitalization, you have to solve the trust issues and the access issues and the maintenance issues involved with data. Right. And I know Aker BP is on a path to become the first data-driven E&P operator. So I think this is a really good step in that direction. Y'all are focusing on things that are really hard to do and using compelling technologies to solve the hard problems. And it was, we've kind of seen this is a really good use case for generative AI because we have some examples, we have some good progress here at showing how we can minimize the manual effort involved, right? I thought, Reza, your demo was very, very spot on, right? If we can do that in 45 seconds more automatically, that's 5x faster than the manual effort, right? That's significant and compelling. And then I think the other thing, if we zoom out a little bit, right, the other thing to unpack here is that generative AI requires kind of an ecosystem of things to make it meaningful and make it work for industry, right? You need still to deal with the data integrations. You have to have data management platform. The industrial knowledge graph is key to making sure that those outputs are reliable and trustworthy. So there's technical components here that are really important to make sure you're thinking about as you're going down this journey. And I'm sure a lot of folks here on the call are probably thinking, you know, what's next, right? What's the next step now that we've made quite a bit of progress here? And maybe first question that we've seen, like, what's next from an Aker BP perspective?
We are going to test it at scale. So we're going back to the previous slide. The learnings is that we can achieve really impressive things when we work together with Cognite, or the technology company going at the difficult cases. So next for us is to test it at scale of some of those identified use cases we have found. Yeah, and put it to work.
Yeah, absolutely. And Reza, what's next from a technology perspective?
Yeah, so what you saw me do, we're hoping to have the feature generally available by end of Q1 2024. The same way of like selecting a group of files, filtering for a group of files, and then running it on a predefined data model that you created, and then populating that data model. And also we're hoping to add some validation steps by that time as well. So
yeah. Great. Well, a lot of exciting stuff on the horizon. I'm sure we'll get y'all both back in here at some point to kind of talk about, you know, the next phase, how it's been, what you learned. It'll be good to check in on that.